Okay, we continue with this topic scalars and vector quantities. And before now, I've done two video lessons on this topic scalars and vectors. The first video lessons I explain what a scalar quantity is and also a vector, and give series of examples. Second video I talked about vector representation, that you can represent a vector quantity both in magnitude and direction by a section of a line segment that has an arrow head, and that the magnitude of the vector is represented by the length of the line, and the arrowhead points in the direction in which the vector is acting. Now, today I'm looking at the resultant of two vectors. Now, vectors already we know have both magnitude and direction, unlike scalar quantities that have just magnitude. And in most cases, it's very important, it's necessary for us to find the resultant of two vectors. And what the resultant of two vectors is the result of compounding two vectors together, is the result of bringing two vectors together, adding two vectors together. Just like in scalar quantity addition, you have two numbers, 5 and 6. When you add 5 to 6, you get 11. So 11 is a result of adding two numbers together. So in vectors, when you add two vectors together, when you combine two vectors together, you have a result. And the result is called the resultant vector. And how do we define resultant vector? The resultant vector is that single vector which has the same effect both in magnitude and direction as the two vectors acting together. Is that single vector that can replace the two vectors that are acting together at a point or on a body. So the resultant vector can be obtained by graphical method or by analytical method. So whichever method it is, the resultant vector is that single vector that must act in the place of two other vectors. So in this video, I'm going to show you how to find the resultant of two vectors. Look at that diagram where you have two boys dragging a box. But to notice that this box moved in a particular direction. That's the significance of finding the resultant of two vectors. You see that now? The box actually moved in one specific direction, and yet the two boys dragged this box in two different directions. See that now? And when vectors are, two forces, for instance, are acting in the same direction, the resultant is the addition of these two vectors, as you can see in this diagram, and then the resultant vector has the same direction as both vector. How about if the forces acting on an object, as you can see in this diagram, they act in opposite direction. So the resultant will be the difference between the two vectors. So now there are three methods for finding the resultant of two vectors. That is when vectors are combined. We have the triangle law of vectors for adding two vectors. We have the parallelogram law of vectors for adding two vectors. And then we have the polygon law of vectors for adding a system of two or more vectors or forces. Now begin with the triangle law of vectors. The law states that suppose we have a displacement vector, starting from point a displacement vector from point A to point B. Let's say that at a time t equals 0, we have this point at A. Then after time t equals t1 second later, the vector body is at point B. And then we have another displacement vector from B to C. B to C. Now the triangle law says that the resultant of this vector AB and BC is AC. That is the triangle law of combining two vectors. Suppose the vector acting along AB is A, both in magnitude and direction. The vector acting along BC is B, both in magnitude and direction. And the vector acting along AC is C. It therefore means that vector C, which is the result, which is the sum of combining these two vectors, is A plus B. So this positive sign is not a normal algebraic positive, because we are combining these vectors. As we combine it, we have to take account of the direction This is combining the two vectors both in magnitude and in direction. Now, this plus sign means followed by. It means that vector A followed by vector B or joined to vector B, meaning that the head of vector A is joined to the tail of vector B. That's how to interpret this symbol plus. Now this is vector AB, that's vector A plus joined by, now here's the head of vector A and this is the tail of vector B, both are joined at point B. Then the result is C. Now let's take an example. Let's say we are given these two vectors, these two floating vectors, given that this is vector A in magnitude and direction, and then this is vector B also given in magnitude and direction. And the question says we should find the sum of these two vectors A and B, and then you find this difference between vector A and vector B. So how do you go about finding the sum of the vectors and then the difference between the two vectors? Okay, and probably let's just find also vector B plus A. Now start by solving the question from here. Now vector A plus B means that vector A followed by vector B, that is the edge of vector A, which is this point, must be joined to the tail. Of course, this is the head of vector B, must be joined to the tail. This is the tail of vector B. So, and then when I want to draw this, because I'm going to show it graphically, I'm not going to change the orientation of the two vectors. That is, the direction is not altered, neither the magnitude is altered. So just the way it is, I'll take my vector A, shift it, and place it here. This is still my vector A. And then I bring my vector B just the way it is. I'll just take it like this and place it here, such that the tail of B is attached to the head of vector A. So when that is done, then the vector C, which is the sum, will have its tail at here at this point and its head at this point. So this is the resultant vector C, the resultant of the vector. So this is how to show the addition of two vectors graphically. Now let's see number 2, which says find the vector A minus B. Now vector A minus B is the same thing. Let's call that, let's say it is equal to vector D. Is same thing as adding vector A to the negative vector B. That is the same thing as saying A plus minus B, which means I must look for the negative of vector B. Now, negative vector B is a vector that has the same length, the same magnitude as vector B, but it is oppositely directed. So this is my vector negative B. That is, it must act in opposite direction to vector B. It must be parallel to it, and it must have the same length. That means the same magnitude. So this is my negative vector B. I'm going to add it to vector A. And again, the rule of addition says the vector B must follow vector A. It means vector A followed by vector minus B, meaning that the head of A must still be added to the tail of vector B. The head of A must be added to the tail of vector B. So I'll still redraw my vector A. This is what was given as my A. I'll take it down here. I place it here in magnitude and direction. I'll ensure I do not alter the length of vector A. Then this is my vector negative B. Now this is the tail of vector B. I must link it to the head of vector A. So just as it is now, this is my vector minus B. Take it here and then draw it, place it here. So this is my vector minus B vector. See that now? So this is the tail of minus B. It is placed or joined to the head of vector A. This is my vector A. So that by the time I close or complete the figure triangle, then vector A minus B is represented in magnitude and direction by this line. So this line gives vector A minus B. Okay, so that is vector A plus minus B to give you this as a result. Okay, I guess you have you understood that. So how do we find the sum vector B, and vector A. Now, how do we find the sum vector B plus A? Recall again that vector A is directed this way, and this is your vector B, meaning that I'm going to take vector B first of all. This is my vector B. Okay, this is my vector B. I'm going to join the tail. This is the tail of A. This is the tail of A. I'm going to join it to the edge of vector B. This is the edge of vector B. So how do I join that? I would like you to join that for me, taking vector A and then join it to the tail, to the edge rather, of vector B. So if you join that together, it will look like this. That's what we mean by followed by. See how vector A is directed. Vector A is directed this way. So the same way this is directed. Recall that we are not going to alter the orientation of any of the two vectors, so that the sum, the resultant of these two vectors, B and A, is represented in magnitude and direction by the length of this line. So this is my vector B plus vector A. Okay, so this is how we arrive at the sum of two vectors. How about if I'm to find vector B minus A? Vector B minus A is the same thing as adding the negative vector of A to that of B. So it's the same thing as adding negative vector of A to that of B. So how do I add that? I'll start with vector B, or come back here now. This is my vector A. My vector minus A is another vector that is parallel to A, the same length as A, but acting in the opposite direction. So this is my vector negative A. My negative vector A is in magnitude and direction. So what I'll do is to draw vector B. This is my vector B, just the way it is. I'll take it and draw it here, just like shifting it, just like translation. The way it is exactly like this. You move it to this point. This is your vector B. Same direction and magnitude as what you were given. Then my vector minus A, this is the tail of it. I'm going to join the tail of A to the edge of B. This is the edge of B, and this is the tail of minus A. So by the time I take this, how do I join that? I can place it like this if I wish to, because vector minus A is directed this way. So that is my vector minus A. Okay, so the result B minus A is a vector that runs from the tail of B to the edge of A. So this is my vector B minus vector A. Okay. Now, suppose you are given this to do, for instance, just told you to just given this closed figure, a triangle, and let's say the vector acting along this line is vector P. The vector along this line is vector Q. See how Q is directed, and in this vector is vector R. Now, they can ask you to write a vector equation that relates the three vectors. You know, the three vectors represented by the three sides of this triangle. How do you go about it? Now, if I decide to start from this point, I can call this point my point O. You can decide to start from any point O. I'm just choosing point O as my starting point. Now, if I want to move this way, if I want to move from O to A, this direction means that vector P will be negative. If vector B was pointing this way, then it would have been O to A will be positive. You see that now? So moving from O to A, that is negative. Then from A to B is also negative, negative R. Then from B to Q is positive. So when you are moving around the triangle, if the vector direction is opposite to the direction of movement, you travel around this triangle in this direction. I'm traveling around. So if I decide to travel around and the vector is opposite direction as the direction of my journey around the triangle, then I take that as negative. Now here again, you can see my direction of travel is opposite. I take that as negative again. But here now, my direction of travel is the same. I take that as positive. I can now equate this to 0. So that vector Q, if I want to make Q the subject of the equation, will be equal to vector P plus R. That is bringing P to this side and R to this side. So this is how we, in the case we are given a closed figure, so vector Q equals the sum of vector P plus R. Now, how do we find the magnitude of a vector, or two vectors rather, using the same triangle method? How do you find the magnitude? The magnitude of two vectors using triangle method. How do you calculate the magnitude of two vectors? Take for instance, you have a box. This box is being pulled by two different forces. The forces act each along this rope. One force act along that rope, another force act along this rope. Let's say I call this 20 Newton, that's the tension in this rope, and I call this one 30 Newton, that is the tension in the second rope. And the angle between the two forces, let's say to the horizontal, okay, let me say it is 60 degrees. We want to find the resultant. Of course, this box will not move in two directions. It's going to move in one particular direction. That's the direction of the resultant vector. So how do I find that? First of all, I can decide to do that by scale drawing, but by calculation, I can translate my figure into this. I can first of all draw my vector 20 Newton, just as it is given here, the same magnitude and direction. And then I know that in triangle method, it is vector A followed by vector B, followed by vector B. So this is my vector A followed by B. So I'll take this and I play just the way it is. I place it and draw it like this. This is vector. This is now my vector B, which is 30 Newton. Vector A is 20 Newton. So it is the same method, the same rule. Vector A followed by B. Now this angle must be 60. Yes. So this 60 degrees is not the angle here. You place it here. So that this one is 120. So the resultant vector is from vector A to B. So this line represents direction and magnitude of the resultant vector, which you can find using the cosine rule. In the next video, I will explain the cosine rule of finding the resultant of two vectors and even the sine rule for finding the direction of the resultant vector.